Hello everyone. So I have an interesting repair project that I thought I would decide to video. And this is a animated snowman that I built, I don't know, 5-6 years ago that has some issues. I'm going to film it out here in my kind of cold garage rather than my nice office because I can't get the camera where I want to in the office. So, and if you notice, the garage is a little messy. So let's look, sorry about that, let's look at what the current state is of our patient. And if we go back here, we'll see he'll turn on. And we can see some stuff changing. Okay, you can see some lights changing. Each of these globes has a dodecahedron with LEDs on it. So I think there are 10 in the bottom, 10 in the middle, and then 11 in the top. And in addition to that, we have the buttons on the middle one, and then the eyes and mouth on the top. And if you look, there's some pretty obvious problems here, especially up high. We'll see. Boy, that mouth is not working the way it's supposed to. It looks like one of the eyes may be missing some colors. It sometimes goes and sometimes doesn't. And then if you come to the side, you'll see there's actually nothing inside the head. The head really doesn't change any colors. It gets a little from bleed from that guy, but not on that. So that's what we're going to be working on. So here's our first look inside the patient. So you'll notice that there's a steel threaded rod that runs through the middle, and that's kind of the armature that everything is attached to. At the back end here, we have a set of these little 3D printed rods that sit on top of each other, and that's what holds the armature in. There's one of those for each of them. Hiding down here in this little 3D printed box is, I think, an old Arduino. I don't know how big it is. That might get replaced, that might not. And then if we get a little closer and look up, you can see there's a dodecahedron there. Now I don't exactly remember how I did the wiring on this thing. I know wiring, maybe we can get a shot here. You can see there's a little hole there into the next globe. You can kind of see it. I'm not sure how the wiring is going to work here, so we're just going to pull things apart, and I think I may have to cut some wires and then come back, and maybe this time I'll put real connectors on them. So I'm going to put this back on the stand. Okay, you can kind of see, I don't have great angles here. So, flip my camera display around, and now, okay, you can kind of see this. Okay, so the first thing to do. Okay, first thing to notice is this is all really loose. And one of the problems I've noticed about this each time I've pulled it off or not is there's supposed to be a fair bit of tension on these so that it holds everything together. But it's been pretty obvious when I've taken it out and put it away. This little nice little part holder. So we're just going to set them. We'll just set stuff here on the side of the bench. So I'm sure we're going to discover some interesting things as I try to pull this apart. Okay, now I pulled off the nuts on this side, and there's a nut on the other side here, back inside. So we have the 3D printed thing that kind of grabs on this way, a nut on the top and the nut on the bottom. So now I need to back off the top nut. And when I back it off enough, okay, I can finally move these around. Trying to remember. Okay. So what I did, you're probably not going to be able to see, but back inside of here, I have a shaft that runs from here to about there, and then there's a hex coupler. So this is a short length of all thread, and then there's another length that'll go into there, and another length that'll go up into the head. So what I'm going to have to do is figure out how to unscrew that. First, let's see if I can get these off. Okay. So that's the first 3D printed kind of retainer. Boy, those really do not want to come off. There we go. Okay. Second 3D printed retainer with some hot glue. And if I put these together, you'll notice one of them has a big angle, another one has a short angle. That's so when they're stacked, this plane, the plane across here, ends up the same. And that's a pattern that repeats inside all of these. Okay, now what I want to do is to be able to undo this. Ideally, unscrew, there we go. Oh, I might not be able to do this with the wiring attached. Ha ha. Okay, what do you know? Okay. This shows how sometimes your memory is not very good. I actually put a little Molex connector. You can see that connector right there. Between the wiring in the bottom, the wiring in the top. I probably had to do that so that I could rotate things around to put this together. So this just got easier than I thought it was going to be. So now I can take this. So now I'm just spinning the bottom parts. And extract out. Okay, so this is the little 3D printed box. You'll see, wow, that's a full Arduino Uno in here, which means this is a pretty old project for me. I haven't used these in quite a long time. So that's an Uno in there. Then this dodecahedron is all printed, 3D printed. Has a hole drilled through it. Somewhere I have the pictures from construction on this, so I'll probably link them in on the description. And you can see I'm just daisy chaining around. These are little WS 2812 LEDs on small PC boards that I bought. I might uprate these. I have something that might work better for this. Okay, so that's the first one. We will set it aside. And I did commonly get a question, what is this? This is actually just a light globe to go over a light that you'd have on like a light pole. And if I remember right, this is a 14-inch one. The middle one is a 12-inch. And then the top, I think, is a 10-inch. Yeah, it's more than 8. So that's a 10-inch. So, and they're just acrylic polycarbonate. So those were pretty easy. So, let me see if I can lift up. If you see inside there, I don't know how well the camera's going to focus, but you'll see inside there, there's another threaded rod with another nut on it. So we're just going to work our way up. At some point this will get worse because of how the upper ones go together. unscrewing, unscrewing some more, unscrewing some more. Okay, nut in the washer. And now we can pull off the bottom. Feed the connector through, and you'll see that's what the top looks like. So I can now set that globe off to the side, where I hope it won't be in our way. And here we are to the next level. This one is going to be a little more fun. Okay, this one will actually have two connectors. There'll be connectors that run out to this, and I'm not sure there are connectors that run into the top. We're just going to have to check and see. So as long as that connector's here, break it. And you can see this guy, notice how loose he is. Okay, when you look to the bottom, you may have noticed I used some hot glue to hold it in. I didn't disassemble to do that on this. I really think what I want to do, there might be some silicone on that. I think I put some silicone on that. But when I redo this, I want to figure out a better way to keep these guys attached to the globe. Okay. Yet another bolt to unscrew. Okay, that's off. Something I didn't show you. So these globes, not only do you figure out buy them by the size, but you also buy them by what sort of arrangement they have at the bottom. Some of them have little flanges that come out that the fixture will grip onto. These are flangeless ones, and they all have, what is that? I think it's a 5.5 inch hole. This might be metric, or it might be a 5-inch hole and it just is a little bigger than 5 inches. Okay, so we've done that. I can move it. There's the first 3D printed guy. There's the second 3D printed guy. And now reach in and do another. Okay, so I've undone, there's a connector. One of the connectors that came in went straight to these three. Then the wires from that come off to a second connector here inside, and that connected to the dodecahedron in the middle, and then the wires coming off to that went to a third connector up into the head. Those are all disconnected, so I can remove the second dodecahedron. I'm just spinning it around. Okay, there's the second guy. He still has washer on it. I left that on the other one. So the second guy looks just like the one we had in the bottom, except of course it doesn't have the controller attached to it. And we're finally getting our way up to the head. Okay, so as I undo this, I can tell that the 3D printed things that are supposed to hold that kind of in place in the head, totally not working. Now, of course, in the other ones you have the rod continuing up, so it's a little easier to keep them in line. Okay. Connector out, and you can see inside that. Let me see if I can tilt it right. There you can see just simple daisy chain. The LEDs for these here are the same LEDs as for these. They're just hot glued, probably. Nah, I think it's siliconed. Hot glued or siliconed to the inside, and then these little button things are just ornamental on the outside. If I recall right, these are actually curved to fit the curvature, so they look flat, but they actually aren't quite flat. So we can take him, set him aside. And finally, we've come to the head. This is going to be a huge pain in the ass to deal with, but so that's the head. One more connector to unplug, and then that's the head. And I think I'm just going to leave, notice how loose that was. I think I'm just going to leave it like that. So you notice he has same daisy chained around on top, and then we have the items here. Now what I'd hoped to do was be able to set this kind of together and run it, you know, kind of in a static mode. The problem is I'm not sure my connectors are long enough. Maybe, okay, so I'm going to futz around with this a little bit, and then I'll bring you back when I have something. Okay, so I managed to have just enough room to kind of put everything together, and we can start looking a little bit more and trying to figure out what's working and what isn't. So let's start at the bottom, which I think worked fine, but let's check. So the question is, are all of these LEDs firing? And yes. And we should watch to see what sort of colors we're getting. Okay, so we saw a full red there. I'm hoping to get everything from a full red to a full green to a full blue. It's going to depend upon where the animation is. Right now it's doing something else, so that one really isn't changing. I guess I could write some test code, but I'm just a little too lazy for that. So we'll give it a second and it'll flip back to something more useful. Okay, now that's pretty much white. That's really useful. Okay, so all that is white. The middle one. Okay, we switch to blue, green, yellow, red. Okay, I'm seeing pretty much everything out of these. And it seems, based on what I'm used to seeing, that I'm seeing a acceptable amount of light out of these. It's about what I expect. They're WS2812s, and that's about how much light they put out. And if we look at these three guys in the middle, I thought they were fine. Okay, we've got some blues, got yellow, which means we have green, blue again, yellow. Let's see if I got something more red. There's red in that. And I don't know, I forget. Okay, so there's a full red. Okay, so that's good. So now, well, look at that guy. Okay, so the first thing I notice is there are a few things going on there. The first thing I notice is that the light output is just pathetic. There's just not much light coming out of those. It's like it doesn't even really show up on the sensor. Look at that. You can't even really see the green there. You can see it more coming off on the t-shirt. But, you know, you compare these. Notice how those kind of blow out the sensor in the camera. Yeah, these barely do it all. So this guy's working. He's just not working very well. And that actually makes me think that it's actually a wiring issue rather than anything else. Okay, so this is this is the startup, which is supposed to be white. Yeah, does that look white? Okay. Yeah, no, that's not white. Okay, so there's clearly something going on. Now this guy is at the end of the data chain. Okay, and he's also at the end of the power chain, and it might be that I just don't have enough power getting out to this. The wires might be too small, and I might have good voltage out here and crappy voltage out here. Now, in general, I don't have that many, and I have a decent power supply, and it worked before, so I'm kind of surprised if that's the issue. So if we look inside that, we'll notice that guy also uses surface mounting. And what do we think about the eyes? I'm going to look at them yet next. Okay, the color they look kind of dim to me, and they have a lot of flashing. And that could be a data problem. One of the things you'll notice, if we get as close as we can to one of those boards, you notice there are no decoupling capacitors on that. And I built stuff using WS2812s without decoupling capacitors, and it's worked fine, but a little farther away from the power supply, and that doesn't seem to be working so well. And then finally we get to this end, and what do we see? Well, I don't know if the eyes are doing what they're supposed to. I'd have to go look at code, and I'm pretty lazy for that. They're supposed to be, the colors here are supposed to match as we go across. Notice that guy, he's kind of shaky. That guy's clearly wrong, right? I don't know what it is, but some of the LEDs along here are just doing the wrong thing. Now, unfortunately, it would be the ones that are worst. So you can see how they're mounted in this really complex curved 3D printed thing I made. It's a really complex shape. And it's hot glued on the inside, and I'm afraid I'm going to have to pull all of that off to see what happens. Now, before we go that far, I want to try something with this guy, just to see what happens. What happens if we take this guy and we hook him up earlier in the chain to that? So I want to see if it's a problem with these LEDs, and I kind of think it isn't, or if it's a problem maybe in the amount of power I'm getting through. I'll give that, okay, well actually I'm going to go grab my voltmeter. We're going to look at power at the end here. See if maybe it's just a power issue. It could be that the power supply I have is crapping out. Okay, so I'm back. Got my voltmeter. We're going to see what sort of power we're getting out here at the end. Okay. So what power would we expect to get here while these run on 5 volts? What power am I getting? Let's set this up so you guys can read that maybe. Power at the end. It's a whopping, these are really hard to get your probes on, especially when you're looking into a bright LED. 2.5 volts. Okay, 2.5 volts is not the right amount of volts at this point. And that explains the behavior that we're seeing with this guy. We can get greens from it, and we can get reds from it. And the reason we can get greens and reds from it is both the green and the red require a relatively small voltage drop. So the physical chemistry of the LEDs, or the physics of the red and green LEDs, their voltage drop might just be 2 volts. So at 2.5 volts, I can get them to work. They don't work particularly well, but I can get them to work. But blue LEDs take about 3 volts to fire. I don't have 3 volts out here, so the blues cannot fire at all. Okay, so that has me scratching my head a little bit. what I'm going to do, we're going to start and kind of work our way out and see, do I just have crappy voltage the whole way? And I've always had this problem, and I just kind of didn't notice it before, or is there something amiss in my wiring? So we're going to come back. This will be much more of a pain to try to measure because I can't see. This is one of the ones on the first. Haha. Okay, 4.93 volts, 4.985 volts. So it'll sag a little, the power supply will, when it's doing that. But, you know, 5 volts, 4.9, perfectly fine. I don't know what the no load input is. I could grab into that connector if I wanted to, but 5 volts is really pretty close. Okay, let's move on to the second guy. What are we getting here? Okay, that can't be the right volt. Okay, 5.05 volts. Okay. That was more, since this is second, that was kind of more than I expected to find there. Try again. And all the way up to 5.2, 4.9, 4.8. It just kind of depends. Okay, that's all the way down to 4.5, which indicates that, you know, maybe I'm a little light on that power supply. So I might go to a higher one, or if I decide to do more drastic work on these, I might be required to go to a higher power one, but those look okay. And let's just see. Undo one of the connectors. Nice about having connectors here. See what we measure. So coming out of the middle, I don't know if you can see that, 5 volts, 5.04, 5.03, 5, 4.9. Okay, so that's all good. There's nothing wrong with that, and that explains why these are all working just the way I'd expect. Especially working better when I pull off the other load. Okay, so let me, just for the sake of testing, I'm going to unplug, and we're just going to kind of keep working our way along the path. So this is the ones that come out of the 3 buttons, out of the 3 buttons here, 3 buttons here, and into the head. So the head part is disconnected, and that's once again a healthy 5 volts. Okay, so now I'm actually getting kind of confused. So we have the healthy 5 volts coming out of here. Obviously I don't have the load of the head, but the head really doesn't have that many. Okay, let's try something. I'm just going to try this. Let's see what happens. We're going to skip all of the face parts, and we're going to plug. It's going to be challenging. We're going to plug the top dodecahedron into the output of the middle guy here. I think that will reach. And I think we're going to see the top dodecahedron work correctly when I do this. Well, we would if I'd actually gotten the polarity on my connectors right. Oh, that's embarrassing. Okay, so this connector, so that's a female, that's a male. At least I think that's how I call it. Ideally, you'd have female, male, female, male, female, male. Yeah, I messed up coming out of here, so I don't have an easy way to connect this guy in to the output from this. And in fact, that's the only set I messed up. So I could try to bridge the 3 across. I find that very interesting right now. So let's connect. Go in. reconnect the head. Okay, that's the face. Okay, we're looking at that. We still have some problems here. Notice that that's clearly not right. Something weird about that series of LEDs. So what we have coming out of that, just for grins. Okay, so 2.5 volts. So there is something going on in this arena from coming in, which we knew, at least when this was disconnected, we were at 5 volts. And now when we hook this one in, we know that instead of having 5 volts here, at the way out of this, we have just 2.5 volts. So something is happening with these guys. Now, one of the things I've noticed, we've watched everything here. I see this is where the input is. You notice there's kind of blue there? You get blue there? Yeah, maybe we are getting blue there. I'm trying to figure out if, okay, maybe I can put a, this is going to be fun. Yeah. I don't know, maybe I can get in there. You go and you glue all these things together. Okay, so I got a reading. This is one of the eyes, and it's 2.3 volts. Okay, that's it. This eye. And let's see if I can get the nose, which is the, comes in here, runs across, and then goes to the nose. See if I can get something on the nose. Ha ha. 2.4. Okay. So once again, it's that. So what have we found? Of course, this is the way it would end up. It's something about this strip of LEDs in the mouth. Not only are they not working right, but in addition to not working right, they're somehow taking 5 volts that comes in and only passing about 2.5 volts out, and that's why everything after them just isn't working well. I'm actually kind of surprised that the eyes look as good as they do, considering all of these are only running on 2.5 volts. But if you kind of compare, you see how bright these guys are? And then you can see the eyes are, yeah, quite a bit dimmer. Oh, this is going to be such a pain in the ass to deal with. Okay, so let me unhook and just to do another test. I'm going to unhook the middle guy. This will mess up the animation, obviously. Oh, interesting. Okay, so I can't do the test I wanted. I had 4-pin Molexes that I used at the bottom, even though I only needed 3, and the tops are done with 3s. And I don't have, I could pull the pins out, I guess. but I don't have an easy way to connect the 4 to the 3 to kind of do a test. But I kind of feel like we've already gotten to the point that we know what's going on. 5 volt is coming out of this, 5 volts going into this, and at some point it's all going to hell. So, okay, I don't think you're going to be able to see this. I'm going to see if I can work away at the hot glue. Oh, this is going to be fun. Okay, so the challenge here is going to be to try to do something to remove the hot glue and try to get it to unhook without damaging either the 3D printed part or the acrylic globe. Okay, I'm kind of making a little progress here. Ah, got a little move. This is probably going to turn out to be just like one of those LEDs mounted. It's just going to be wrong. And everything else is going to be fine, but the one guy is going to be the one who messes up. That's my current prediction. So what I'm doing is trying to get the screwdriver just under the hot glue so I can kind of put some tension on the 3D printed guy. Not working as well as I'd hoped. Try a smaller screwdriver. Ah, that's it. So luckily, I actually used hot glue here. One of the alternatives would have been to use some acrylic adhesive. And if I'd made that choice, that would have been really, really bad. Because the acrylic adhesive actually melts the acrylic. It does a solvent bond. And if you get a solvent bond, you want to take it apart, you are essentially screwed. Haha! Okay. One side away. I'll do this pretty slowly because the shape is pretty complex. Now for both, just for the sake of argument, if you look closely at this guy, you can see he's a really complex shape. Look at the edge. And essentially that's built by, I took a curve. You can see they're actually face. It's not a smooth curve. And then intersected it with a globe of the right size to create this, and then 3D printed. That took, I don't know, 2 or 3 tries. And same thing about the eyes. The eyes are also cylinders with a, 10-inch globe intersecting. It's making good sounds. Yeah, well, that's almost perfect. I ended up with one, oh good, a spider. Did find some bugs in here, which kind of surprised me. So, I don't know if you can see that. We just have a little series. Let me take the camera down so that you actually can see it. Okay, so that's what the mouth looks like. So it's just a series of those along there. And they're just those little modules. Let's see if I can get them to, Dice really doesn't want to focus that close. There we go. So really, really simple. Modules just glued on around and just tied in. So somewhere along here, something weird is going on. Okay. We are back. Okay, so let's wire things up again. So I'm not going to bother hooking in the top guy because I don't think he has an issue. So we'll take the face one, run it into the middle. Luckily these holes are just big enough that someone like me can fit 2 hands in. Okay. Hope you can see that. It's always hard. These first 4 look pretty good. The brightness looks, yeah, I don't know, maybe down a little. And then we get to here, the second 4, and they just kind of go to crap. Now they're clearly not getting blues in here, but it also looks like the data's not getting there or something else. So let's put some voltages. Maybe move that so it's actually readable. I was expecting 5 volts here, and 5.05. Okay, let's go down to where I think things mess up. Ah, 5 volts right there. Oh. Okay. I think there's a bad joint here somewhere. Something about me touching this flipped it into, hey, I all work mode. For a second, I had full white. Oh. Okay, now I have 2 volts coming out. Oh, and now I have 4.6, 4.7. It's working fine. And I pull my probes out, and it doesn't work. Which suggests that I have a bad solder joint somewhere. Either that or one of these modules is messed up. Generally what I expect, so for the WS2812, so you have 5 volts running at the top of the modules, and then you have, ground at the top, 5 volts here, and then the data ports are just chained along, which is exactly what I'd expect. What this is behaving like is that somewhere in one of these connections, I don't have my magnifying head thing on, so I can't tell. There's either a problem in the module connection or a problem in the connection I soldered. It felt more like a module connection. I'm going to try this again. Because of course, how likely could it be that I made a mistake with my soldering? Okay, so that's messed up. One thing I usually really like to do, if you think that there's a mechanical issue here, and you notice, boy, I have a big mechanical issue, try pressing on the LEDs. Because a lot of times when it's solder joints or mechanical stuff, it'll just be interesting. I press on it, I think, well, 2 of them are working, and then the 2 farther on aren't working at all, which suggests, cold solder joints or something like that. If I press it, I'm pressing down hard on the joint, and I think it's doing exactly, it's behaving correctly. I like it when it stops. Press hard, on, down, stop. Press hard, on, down, stops, which means it's probably, I can also see when I do this inside, I'm also getting 5 volts to the other ones, the eyes and the nose. Okay. And now pressing doesn't work anymore. Well, now maybe it is. It looks like I actually had problems all along here. So it could have been I just soldered it bad. It could have been a number of other things. What I'm going to do is, since my nice soldering stuff is downstairs, I'm going to go down there where I have everything, take the top down, and then I'll come back and we'll see if I've achieved anything. I'm just going to reflow all of those. And let's hope. Is the strip, and I've looked pretty closely under magnification, and I really don't see anything that looks like cold solder joints or anything like that. So I'm just going to go through and reflow all of them, maybe add a little solder, and then we'll go back outside and redo them. It's possible that the solder joints expanded and contracted kind of at a different rate than the plastic and everything else, and that was enough to kind of break something. These little modules can be kind of sensitive or fragile. Okay, so I'm done soldering, and when I was soldering I found a couple places there might have been some breaks in the lead in the solder. And one of the things I noticed is because of the curve at the top connections and the middle connection, I used a little piece of wire to bridge the gap. And at the bottom connection, I just soldered the edges together. And I kind of thought that maybe the solder to solder joint just wasn't enough. So when I went back and reflowed them, I put in little pieces of copper at each of the bottom joints, so they look kind of hefty. And you can see the copper on 1, 2, 3, third one from the right, if you look closely. And I'm hoping that will give us voltage all the way across. So I went in and did all the soldering. Probably saw that in the other video. And I think we may have accomplished something. So I have this guy plugged into the head, and now we're going to plug through to the others, and let's see if we've accomplished what we're hoping, or if we're still in a crappy state. Okay, so the first thing I noticed is these guys have quite a bit more brightness on them. They're actually kind of hard to look at, and that's a really good sign. And what do you know? They reset, and they go to white. Let's look at a little voltage right here near the end. This is kind of the worst. 4.4. Okay. Yeah, it's not 5 volts. But it's 4.4 volts. It's a whole lot better than 2.6 volts. And if we, I don't know if I can turn this towards you. If you can see that, you'll see that's both quite a bit brighter. And they all look the same. And what do you know? Look at him. Okay, so I think we have found the electrical problem. And we're back functioning. Back functioning at 100%. So the next thing will be reassembly, and I will do a video on that. Unfortunately, I'm going to call this a day right now, since my hot glue gun went walkabout, and I have to go find the tour guide and who can tell me where it went walkabout to. But I think we accomplished pretty much what we were trying to. So that's all we have now. I'll be back as soon as we hot glue. I'll probably do the hot gluing, and then I'll do a video of the reassembly and working to try to figure out how to attach these guys a little nicer to the inside. They are coated with silicone. I may just put a big glob of silicone where I want each of them there, and then just wait for that to cure. And that would probably give me a better, certainly better than what I have now. Here we are back in the garage. Time to finish fixing up the snowman here. So the first thing we need to do, kind of look inside there, you can see barely across the bottom. You can see the little face part that I have temporarily taped in so that it's in the right space, and we're just going to glue it back with the hot glue the way it was originally. And then once we have that, it'll just be a matter of putting everything back together again. Okay, of course. My hot glue gun here is kind of a sharp cord, so I might have to pick this up and move things around a little bit. I'm going to mostly see if I can just melt the existing glue back, maybe add a little bit. A little bit of new glue, that'll heat up the old glue, we'll get a nice bond. I don't want too much because it'll be kind of visible from the outside. Could also have used silicone here, that would have worked just fine. Hot glue, of course, has the advantage that it sets up nice and quickly. I'm doing the inside that I can't see, which is always fun. Okay, first little bit, take off the tape that's inside. How we're doing. Now it already feels pretty solid. There. There, and well, you know, it'd probably be a good idea to wire this up real quick and make sure that the face looks the way we expect the face to look. I, of course, just unhooked everything here. Top guy. Plug her in. Should turn on everything except this top part. It isn't. So let's see what the mouth looks like. And what do you know? Mouth looks pretty good. There's a little bleed top and bottom, but pretty good. It's probably the way it was before. So I think we're going to call that functional. So, unplug. Now it's time to start putting things together. First part, and I've decided to keep these pretty much the way they are rather than doing a bunch of different changes. This top, oops, need to fix one. Those guys got pulled loose. So we'll do a little hot glue to hold that back. So this top piece will go back inside the head of the snowman. how is he held there? Well, let's before we put him back in, let's plug him in first. He connects after the eyes. He goes in there. And the only way he's held together is through connecting this through the other top. So that gets fed through. Rotate it around a little. Need to fix this top so it's kind of equidistant around. And then at that point, the easiest way to do this is actually to, well, I guess it's not the easiest way to do it. What I need to do is put a washer and a nut onto that. I tried when I was building with this to see if I could come up with a better way to hold that top guy in, and I really didn't figure anything out. So now I have to hold it. I'm holding tension with one hand while I'm screwing on the nut with another hand. Luckily there's enough space inside the globes for me to fit my hands inside. Sorry, this isn't very photogenic. All you get to see is me whining as I'm turning these by hand. I don't want them too tight, but I want them kind of firm. Okay. So those two together, now I need to line them up. We'll twist around, and that's the first two together. Okay. Unhook. Now, oh, pulled some more off. Seems like it's going to be a theme. More to glue back on the dodecahedra, I guess. Time when hot glue is just about perfect. Okay, so now I have this piece. That's the middle one. It's going to go in and spin until the connector is tight, and then I can hook up, and then we'll go against this nut. It's reasonably tight. What do I need to hook here? I have so the connector from the dodecahedron in the middle goes to the buttons on the front. And I have this connector coming out, which is finally going to go against that. So now I have a set of these to go back on. We turn this and make this slightly more photogenic. Okay, so these two are going to go in like that. See, we already have a nut where it was before. We'll kind of hope that's in the right spot. The washer goes on. Upper one goes on first. It's supposed to have enough slack that I can kind of push it to the side like that. Wow. Okay, that was not supposed to be that hard. These are supposed to rock back and forth much easier than that. This one looks like it can't. Probably just didn't push it in enough. Okay. One side. It's supposed to be kind of tight. So that the tension from these little pieces holds everything together. Okay. Yeah, kind of rotate it a little, but you can see that one's off a little, but so now we're pretty much centered. About the right number of washers. Okay, that's nice and tight there. Now, big globe comes on. No matter which direction he's in, but feed the wiring through. It's a little easier at this point because the other ones can't move. First one's really the big pain in the ass. There's a big scratch there. Yeah. Okay. In. Washer on, and then a long segment. Bring that together. That one I'm going to be also pretty tight so that things don't rotate too much, but not enough that I'm really putting any big stress on the plastic. I thought about putting some gaskets in between these sections. That might give a nicer result, and in the end I just decided I was going to be more lazy. At this point we just have the main base, the main dodecahedron, and it also has the Arduino and stuff connected, so I'm going to have to rotate all these at once. It's already pretty ugly. I don't want to make the wiring any uglier. And those all look okay. One hand to rotate the controller, and another hand to rotate the all thread bar as far as it goes. Okay, so inside, one more connector to hook up. And then finally, down here in the bottom, we have the last set of our alignment or containment pieces to go in. goes on. The upper one goes in. Finagly. Lower one goes in. This time I'm smart and I'm remembering it goes in. Put it in at the same angle. This is easy. Then you can rotate them. And what we're going to find here is ideally you want these to be pulling back tight against the bottom. That's how it's held together. Of course I probably undid this when I took it apart, so now I have to tighten up the nut on the back side. So that we can actually have some clamping tension by these arms. This we kind of get two ways. We need a little clamping tension just to kind of hold these in the right spot. The final tension will of course come when we tension pulling this down, and that'll hold them in a little better, but we need to have this in the right ballpark. Okay, I'm going to call that. Yeah, it's funny. It really doesn't want to center. In the end, it doesn't really matter if this is perfect or not, as long as I can get some clamping pressure. But it's kind of annoying that it's not perfect. I tried with using some hot glue to help hold these in. I think I've kind of decided not to. Maybe after I get them in, I might put some in just a little help. Okay, so since they're trying to jump out of the way, it's the last washer and the last internal nut. What's happening is the actual lip of this isn't really built the way we'd like it to be. I'm going to turn them a little and do just a little hot glue to make this stay a little nicer. Maybe, before we do that, let's actually just plug in some power and see what we get. And the winner is, turn that towards you. What do you know? What do we see? We see all three globes, dodecahedron are lit up. I don't know if you can see through this. I can actually kind of just see the LEDs inside, barely in color. You see they all have different colors, all the lights are working, the buttons are working, and the face is working. And I would call that success. So let's This is the very, very precise drizzle method, where you just drizzle a little hot glue between these 3D printed pieces and the acrylic with the hope that it's just going to kind of give it a little fixing. It doesn't have to be perfect. It really doesn't have to keep it from moving too much, but just keep it from easily coming loose. There. Now there's one more step. You can sit and watch this. Hey, puppy. You ever wondered where a snowman lives? He lives in a box like this. Hidden in the bottom of this I have what I call his travel base, which is just a little piece of 2x6 hole drilled in it, and then a little recess. And the reason we have that is, once I've tucked, we may have made a mistake here gluing those in. Okay, that was a tight fit. The Arduino and stuff just sits kind of on the inside at the bottom. And then we try just, kind of not to worry about it. So once we have all of that in, when it's in display, it's mounted on a little aluminum bench I have back there. But for storage, this gets mounted to the bottom. Helps hold all the weighted parts together and makes it easy enough to pick up. This will let me set it up right. It's not enough to use as a display because it would just get blown over really easy. But it's enough just for what we're trying to do here. Now, let's flip him up, see if he sits. I'm going to have to back up a little and reframe here. And there's the full snowman. I think his head is off just a little bit. You might feel a slight pinch. That looks pretty good to me. And let's see what we get. Turn off the lights. As usually happens, the LEDs tend to just really overflow the sensor. I can tell you the colors that are showing up in the globes themselves are pretty close to what I'd see. Not quite as vivid, but pretty close. Greens look really good, and red's not quite as good. The colors you're seeing in the buttons and in the face parts are pretty wimpy compared to what they really are. So it looks like we now have the snowman back in his original state. Have a few shadows from the interior lighting, but I think all in all it really doesn't matter that much. So thank you for your attention. I hope you had fun and enjoyed this.